Let's write the balance equation for the reaction between sulfuric acid, we're given the formula, and barium chloride in solution. To find the formula for barium chloride, you can use the charges on the ions. So barium, being in group 2, will lose 2 electrons, become 2 positive, and chlorine, being in group 17, will gain 1 electron and become 1 negative anion. You can crisscross these numbers to the subscript of the other element to get the ratios in the formula. So the formula for barium chloride is BaCl2. So notice you have 2 compounds before the reaction arrow. This indicates you could have a double displacement or double replacement reaction. So switching the cations in these compounds will give you the products. So let's pair up hydrogen with chlorine. The formula for hydrogen chloride is just HCl, and because this is an aqueous solution, this is hydrochloric acid. Now the other compound is going to be barium with sulfate. Because sulfate has a 2 negative charge and barium forms 2 positive cations, they're going to reduce down to a 1-to-1 ratio. So the formula is just BaSO4. Now this is going to be your precipitate. You can see that sulfates are generally soluble, but one of the exceptions is when it's in a compound with barium. So that's how we know this is going to be your precipitate. And the formation of that precipitate is what drives this reaction. Alright, now we need to balance this equation. We have 2 hydrogens on the reactant side and only 1 on the product side. So we need a coefficient of 2 before the HCl. That's also going to balance the chlorines. So here's the balance equation for the reaction between sulfuric acid and aqueous barium chloride. In a later video, we'll see that these compounds are actually dissociated in water. In other words, they'll separate into their ion species. And we'll learn how to write and balance net ionic equations.